Hi, today we are going to see about what's low power cardiac architecture for 5G applications. Actually, what's low power cardiac architecture? So, in modern days, we are using mobile phones and research about wireless communication, satellite communication. So, what's the major thing there? So, the thing is the power consumption and the hardware thing. So, here we are, that means how we are going to reduce the power consumption used to by that and hardware element, which means the thing is handy. We have to, if we take a mobile phones, it should be handy for us. It should not consume more power when we are using it. So that's the thing we are going to see here. So uh, yeah, so introduction about the cardiac architecture. It's widely used in digital signal processing for complex computations such as trigonometry, vector rotations, those things. And FFT is generally used to see in DSP, digital signal processing there. So that's the major thing applied here. So which means so the low power architecture means which means optimizes the algorithm and hardware. The hardware achieve high performance while reducing power consumption. Which means the hardware element, which means the hardware thing should be achieve high performance, even though if we reduce the power consumption. So in the development of low power architecture, is an active area research and technology to play a role great design of future electronic systems. Which means the speed is a requirement as an enhancement impact to solve real-time issues. So in fact, it makes suitable for battery operated devices applicable with limited power budgets. So if we see this, so what's the problem identifications we say there as hardware efficiency, power consumption, memory utilization. Usually when we take a system, the first thing is we have to reduce the size of it. So in order to reduce this, we have to reduce the chips used in it, but the efficiency should be more even if we reduce it. That's we are actually using these cardiac architectures. So in the past conventional cardiac, the hardware efficiency is not the power consumption is not the memory utilization is not, but these things are there. It holds a um, which means it holds sufficient memory and power consumption is there, which is not lesser than what we are proposed here, but hardware efficiency is normal there. But the thing is, when we are reducing the memory, the hardware element is reduced, which means the chips are reduced. If we reduce the program, if we reduce the size of the memory, so that the chips utilized by the hardware elements are reduced, then the power consumption is reduced. So it is more suitable for applications like 5G. It means it's a newest application, it consumes a lot of power, but for such kind of applications we can use this. And then this is the block diagram proposed diagram, and given the input data in the previous conventional, we will give you only serial or a parallel to the cardiac, but here we can give the serial to parallel converter, and we can get the output of serial to parallel converter. That's the thing here. But M cardiac, which is the modified cardiac here, which means usually the cardiac architecture is they use a shift register, but here we use a barrel register, which reduces the it reduces the number of iterations it takes. That's the thing here. And then if you see, yeah, well, when you are comparing the proposed system with the yeah, this is the existing system here. If you see here the utilization of the vehicle, get the memory element here, but we but with our identification, we will remove these memory elements because this memory utilization plus flip-flops, this both were added. Yeah, that's the thing, which is reduced there. And the power consumption is 13.975. That's too much. When we are proposed, we will get this so reduced, which means 1 by 4 times reduced. Yeah, that's the thing here. Thank you. Yeah, well, this is the final output of the proposed system. The chip is reduced here. And if you see the table here, yeah, the FF, which means flip-flops, and LUT means it is the utilizations. The FF flip-flops is 2766, which is reduced, and utilization is it's nothing but it's how much it is utilized. That's the thing here. The major achievement we are gonna see here means which is a flip flop. That's how memory access and the power consumption is far reduced here when we are comparing it with